Hello everyone and welcome to the Math Bender. I'm Adnan Zaidi, and in this section we'll discuss sequence and series and extension of it which leads to sum to infinity. So before seeing what sum to infinity is, we need to have a quick idea what do we mean by convergence or divergence. So far we have done arithmetic progression or arithmetic series. So when we are adding up or we are subtracting, for example, 1 plus 3 plus 5 plus 7, and if I say where will it end? So we say that the sum of all the terms, since this means that the series is going, it's not stopping anywhere, and I'm not specifying that which term are we taking the sum till. So if I say that it is reaching infinity, so if I say what is the sum to infinity of it, we'll straight away say it is going to be a very large number, hence infinity. So any sum that does not come to a finite number, we say that that series is diverging. Any sequence or series that does not end at any point, so the sum is not a finite number, we say that. But if I say in a geometric progression, let's say GP or series, so 2, 4, 8, 16, I can see that in this the ratio is 2, the first term is also 2, and as I can see that if I keep on writing those terms, so if like it's going to be 32 after this, 64 after this, and so on, the series is not ending anywhere. And if I say what is the sum to infinity, like if it is not ending, it is going to have a very large number in the end. If I add those very large number until then, what is it going to be? So it is also going to be an infinity, and hence diverging. But another case of geometric series, if I say 64 plus 32 plus 16 plus 8 plus and so on, as you could see in this series, it is every next term is a division of the first term by a number of 2. So in this series, the second term is a multiple of 1 over 2, and the third term is also the same. So the ratio is 1 over 2, and the first term is 64. Now as you could see that after 8 there is going to be 4, then 2, then divide by 1, then 1 over 2, and it is decreasing every instant, every next term. So we consider that eventually 1 over 2, 1 over 4, 1 over 16, 1 over 32, it will become such a small number that it will attain a value of 0. Now when we say that a value of 0, but since every next term is half of the previous term, when will that be that it becomes 0? Because every smallest bit of number that you will have, the next term will be half of that smallest number. So it becomes so negligible that it becomes 0, and hence we assume that when it reaches an infinite number of term, it will become 0. That's our assumption. And we say that some infinity will be a number. When I add all those terms, it will be a number, and hence the series converges, because eventually it is getting a converging pattern. So if you add all those numbers until the term infinity, you will get sum to infinity as a whole number, and we can look at that. So sum to infinity of a geometric progression is a over 1 minus r, and you can find out the sum to infinity using this. So if we look at it in a geometric series, there are two types of patterns as you observe. One has a ratio bigger than 1 and one has a ratio lesser than 1 but bigger than 0. So it will become, so for divergence or divergence, R can be anything, but for convergence, this is what we need to know only. Modulus of R, like the positive value, has to be less than 1. This is the convergence condition, that if it is less than 1, hence it will become a decreasing pattern in manner it will be a multiple of 1 over 4, 1 over 2 or any number, and that ratio, if it is less than 1 and greater than 0, it is a pattern that indicates that it's going to converge. Let's look at some of the questions here. So if you look at the first one, and I can see that 3 plus 1 plus 1 over 3 plus 1 over 9 plus and so on. Now if I take the data out, the ratio here is going to be 1 over 3 and the first term is 3, and sum to infinity, if I take it out, it will be a over 1 minus r, and in this scenario 3 over 1 minus 1 over 3. So S infinity becomes 3 over 2 over 3 and 9 over 2. So it means that if you add this, all of these, it will eventually give you a value of 4.5 until you add all the terms that are there in this series. Now let's look at another question here. So if we have 8 plus 8 over 5 plus 8 over 25 and so on. So in order to find the sum to infinity or check whether it is converging or diverging, so R is going to be 8 over 5 divided by 8, which is going to be 1 over 5. And the first term is 8. When ratio is less than 1, as you could see, we do get the idea that it's going to converge. So S infinity is a over 1 minus r, and 8 over 1 minus 1 over 5, which is 8 over 4 over 5 or 10. So this number means that if you add this, and all the terms till infinity, the number will be a finite number, which is going to be 10. Okay, now here, so the second term of a GP is 6.5. There's a progression in which the second term, I can say u of 2, the second term, which is 6.5, just collecting the data right now, and sum to infinity is 26. Find the common ratio and the first term. So first step, whenever you have a situation like this, you do revert back to what they are. U2, as you know, that u of n is a r to the power n minus 1, and u of 2 is going to be a r 2 minus 1. U of 2 is equals to going to be a r. Now for next thing is S infinity is a over 1 minus r, and S infinity in this scenario is going to be a over 1 minus r, which is equals to 26, and here AR is equals to 6.5. Now this turns out to be a is equals to 26 times 1 minus r, or a is equals to 26 minus 26r. Okay, so you can plug in the value of a in this. So instead of a, if I replace 26 minus 26r times with r is equals to 6.5, and I can see that 26r minus 26r square is equals to 6.5. 26r square minus 26r plus 6.5 equals to 0. And then solving the quadratic equation, I'll use a calculator for it. So 26 minus 26 and 6.5 gives you r as equals to 1 over 2. So the value of r is 1 over 2, and hence it proves it was converging, hence it had a number as sum to infinity. So now, since we know that a times 1 over 2 is 6.5, just plugging it in this equation, so a is equals to 2 times 6.5, or a is going to be 13. Now let's look at another question here. So there are three progressions in fact, three progressions. They are geometric p, q, and r, such that their sum to infinity of the first three terms of an arithmetic progression. So let's look at it, try to make a rough sketch of what the question is asking for. So it says that the sum to infinity of p and sum to infinity of q and sum to infinity of r are the first three terms of another arithmetic progression. So for p, for an arithmetic progression, let's write this down. The first term will be the sum to infinity of p, then the sum to infinity of q, then the sum to infinity of r. These are the first three terms of that arithmetic progression which we are trying to construct. Now, so when we say that the progression p, so for p what we do is a is going to be 2 and r is going to be 1 over 2, and s infinity is a over 1 minus r, which is going to be s infinity of p is going to be 2 over 1 minus 1 over 2, and you can do the math, it becomes 4. So this is the first term of that arithmetic progression which we are looking into. Now looking at the second for q, so a is equals to 3 and r is equals to 1 over 3, and sum to infinity of q is going to be 3 over, I'm directly writing that down, 1 over 3 is going to be 9 over 2. So that 9 over 2 comes here as the second term of that AP arithmetic progression. In order to find the sum to infinity of r, and it is already been established that it is going to be the third term of arithmetic, that the new arithmetic progression. So it's pretty straightforward that if you find out the common difference and find out the third term. So 9 over 2 minus 4 gives you 1 over 2. And if I add 1 over 2 to 9 over 2, it gives me the third term, which is going to be 5. So sum to infinity of r is 5. Now given that the first term of r is 4, so let's write down the data that we have gathered so far. So S infinity of r is 5. The first term is now as 4, and we know that S infinity of r is a over 1 minus r. So instead replacing that with 5, a with 4 over 1 minus r. So 5 times 1 minus r is equals to 4, and 5 minus 5r is equals to 4, and r is going to be 1 over 5. Now we need to find out the sum of the first three terms. So Sn in this scenario, since ratio is less than 1, we write a 1 minus r to the power of n over 1 minus r, and S3 is just putting the values of a as for 1 minus 1 over 5 to the power n, which is 3 in this thing, and 1 minus 1 over 5. Just writing that down as it is. This is 124 over 25, or 4.96, sum of the first three terms. So let's look at another question here. Now this is a different type of questions which is now applicable on AdMath, but it does come with A-level mathematics as well. The first term of a GP is root 3, so writing the data down as root 3 as A. The second term is 2 cos theta. So let's write down the sequence now after looking at it. So root 3, comma, the second term is 2 cos theta. Find the set of values of theta for which the progression is convergent. This is what tells you the direction, the approach, where are you going to head now. So for convergence, we know that the modulus of r has to be less than 1. So in short, ratio has to be less than 1. So if I take this out, the ratio here is going to be 2 cos theta over root 3. So writing that down, so 2 cos theta over root 3 has to be less than 1. And then multiplying it over there will gives you 2 cos theta is less than root 3. And cos theta is less than root 3 over 2. Now there are two ways. If you could look at the value of graph as well, that works. But let's take the conventional approach here. Find out the value of root 3 over 2. And as we know that cos lies in the first and last quadrant if it is positive. So it is theta here is going to lie there, or so the domain of the question, the domain of theta has to be less than pi, which means this angle is of no use. Now we don't need to find that either. So taking out the value of cos theta, converting your calculator to radian mode if you haven't. I did not. Now I just did. So shift cos root 3 over 2 gives you pi over 6. Now this means that the value of theta is pi over 6 when cos theta is root 3 over 2. To make a proper inequality context, we need to roughly sketch the graph of cos theta. And when I draw this, I can see that this is how the graph is. This value here is pi. This value here is when cos theta is 0 is pi over 2. This is 3 pi over 2, and that value here is 2 pi where the cos theta reaches 1. And the bottom value is negative 1. Now, what we are focused on is somewhere here is root 3 over 2. So, now if I highlight the value where cos theta, the graph of cos theta is less than root 3 over 2, so writing that down, value is root 3 over 2 here is this value. And until this, the region is between 0 and pi. So we don't care about what is going to be ahead of it, but all we are focused on is until pi. So I can say that at this point, the intersection, the value of theta is pi over 6. And I can say that theta lies between pi over 6 and pi. This is how the modulus of r is going to be less than 1 and hence converging. So this was it about geometric progressions, infinity, and converging series. I will discuss more practical based scenario questions related to sequence and series in my next session. Until then, take care. Bye.